How's it going?
Oh, very
Good. Good morning. Okay. So before we get into class today, I want to point out that, let's see, let's get over here. I want to point out that the 30th is the first day of exams. Okay, so what does that mean about our calendar here? Well, here we are on the 12th, and here's the 30th. That is not a whole lot of time. Okay, so we got this week and next week, which we'll be going through, normal stuff. But then the last week here, this is going to be dedicated to preparing for that final. So again, the 30th, Friday, is a exam day. And then this Thursday right here is a dead day. It's a day dedicated to let y'all study and prepare for your exam. Besides that, we have Monday and Wednesday of that week, and that's it that we will meet. So again, Monday and Wednesday of that week, we'll be reviewing for the exam, preparing y'all. What were you going to say?
You said the 30th of this month is the final day?
That's their finals.
Yeah, right here, right?
Yeah.
That's the first day of finals.
Okay.
And then, that's a Friday. Then Monday of the next month is the last day of finals. Okay, so we have Friday, and Saturday, Sunday, and then Monday. And those are finals. Any questions? All right.
Oh, I got a question.
Yes, sir.
When are you going to take your final?
My final?
Mm-hmm.
Probably Friday. I'm just gonna put it online. Y'all do it. And it's gonna be just like any of the other exams we've had over the semester. So, I'll release the review and then we'll go over the review, and everything you see on the review is what you can expect to see on that exam. Okay, so let's get into our new section. So far this semester, we've talked about all sorts of different topics. Whoops, that's too far in. There we go. Again, so far this semester, we've been talking about all sorts of different topics. We've talked about expressions and equations and inequalities and whatnot. Now we're going to get into a new type of thing called a function. Now, a function isn't actually all that different from an equation. The big thing is the way that we work with it. So let me give you an example. So let's say we have an equation like 3x plus y equals 2. Okay? 3x plus y equals 2. Notice that there are two variables in this equation. In fact, a function will always have two variables, at least two variables. Now, a function has particular form to it. This one right here, by looking at it, I see that the x has a single power on it. Same thing with the y. The y is only to the first power. This is what we would call a linear equation, and it will make a linear function. Remember, a linear equation is one that when we graph it, it makes a line. So what we want to do with this right here is we want to change the form, change the way it's written right now, so that it is now in standard slope-intercept form. That's y equals mx plus b. Okay, so we want this to now look like this. Well, the big thing that I see that is different between these two is that y is solved in this one. So that's what we want to do. We want to get y solved for. So it's pretty easy here. All we need to do is move what? What are we going to move here to get y by itself?
3x.
Yeah, so subtract that 3x. Do that from both sides, of course. And that gives us y equals 2 minus 3x. Is what you might say. Now, it's fine to have it like that, but we really want it to look just like this form. And what I see here is I have a 3x, I have mx right there. That's in front of the b. So I want to switch the position of these two, just so that I make sure it has this exact form. So when I switch that, it's going to be y equals negative 3x plus 2. Any questions? Okay. So now that we have it in this form, what does that form actually mean? We got y equals mx plus b. So first of all, y and x. When we're dealing with a function, we can plug in things for x and we get something out for y. In fact, the proper way to write this to show that it is actually a function is not to write y, but actually to write f of x equals negative 3x plus 2. Why? Because this says now that this number here, f, is dependent upon what x is. So we plug in a number for x and we will get a number out for f of x. In fact, I can go ahead and use this function to find some values for y and x. Okay, the values I usually plug in to test are between negative 3 and positive 3. So I'll do negative 3, negative 2, negative 1, 0, 1, 2, and 3. And let's see what happens when we plug these numbers in for x. So for instance, this first one, negative 3. If I were to plug that in, that would be f of negative 3 equals negative 3 times negative 3 plus 2. Does that make sense? So if we solve this, let's see, negative 3 times negative 3 is positive 9. Positive 9 plus 2 is positive 11. So we would say f of negative 3 is positive 11. And we record that in our chart. Now, we can do the same thing with all these other numbers. Plug in negative 2, plug in negative 1, plug in whatever. But for the sake of space on this paper, I'm not going to write them all out. I'm just going to go ahead and do them. So f of negative 2, that's negative 3 times negative 2. That's positive 6. Plus 2 is 8. Negative 1 is positive 3. Positive 3 plus 2 is 5. Plug in 0. 0 times negative 3 is 0, plus 2 is 2. Plug in 1. 1 times negative 3 is negative 3, plus 2, that's negative 1. Two times negative 3 is negative 6, plus 2 is negative 4. And then negative 3 times positive 3 is negative 9, plus 2 is negative 7. And of course, you could do more points. You could actually do less points. Not a great idea, but you can. Really, the minimum amount of points that you need is 3. But from this, we can see a trend. our x and our y values, if we compare them to each other, as we increase x values, what happens to our y values? Do they increase or decrease? Decrease, yeah. And in fact, you can see the rate at which they decrease, can't you? Now, making a t-chart like this is a great way to make a graph of a function. I'll get to that in a minute, though. Again, what I really want to point out is that when we have this form, y equals mx plus b, the y and the x just are values. Some value like negative 3 and 11. If we plug in a negative 3 for x, this y would be 11. M, however, is not a variable. M is going to be a constant. For instance, in our example here, m is negative 3. But what is m? Is what?
Negative 3.
Yeah, that's why I just said that.
Well,
But what is m? What does it actually represent mathematically? M is the slope. M represents how fast this changes and in what direction. Slope tells us if the if the function increases over time or decreases over time. We see that as our values increase here, that our y values decrease. So this would be a decreasing function. So our m, in this case again, is negative 3. But slope is actually not read that way. Slope is read a very particular way, and that is y over x. Or you might hear it as rise over run. So both of these ways are fractions, aren't they? And we can make this into a fraction by doing what to it? How do we make 3 into a fraction? It's a lot easier than making it out to be. Put it over 1. So negative 3 over 1 is a fraction. And this can be read now as a slope, our rise over run. There's a couple of parts to this, though, and I want to go over the parts. Okay? First of all, the negative. Or whatever sign is there. It could be positive. Whatever sign is there tells us if the graph increases or decreases. Okay, so once again, that sign tells us if the graph increases or decreases. This is a negative, so that tells us that the graph is going to decrease. So if it's negative, your graph is going to look something like this. It'll go down. If it's positive, then your graph will do the opposite. It will increase, like that. Any questions? Okay, next, this top number, the numerator. Like this suggests, this tells us how much we increase or decrease on the y-axis. And like this says, it's the rise. How much do we go up or down? Which means that the bottom one, the x part, or the run part, does the opposite. It tells us how many steps we go on the x-axis. Now once again, the slope tells us how fast we increase or decrease. So that's going to tell us, like this number, we're going to either go up 3 or down 3. In this case, we're going to go down 3. But x doesn't have anything to do with going up or down. X has to go with left or right. So which way are we going with this? Are we going left or right? We will always graph right with this. So if this says go down 3 steps on the y, and this says go right 1 step on the x. Always right. Any questions? Okay. What about that last part? Not the M, but the B. B is the y-intercept. It is the physical location where the graph crosses the y-axis, which in this case is y equals 2. Okay, so let me go over this one more time for us. If we have an equation that has 2 variables in it, we should automatically know, hey, that's a function. Or at least we can treat it as a function. And doing that, we should put it into the form of a function if we want to use it as a function. So we can solve for y, get it into this form, and then really we need to have it f of x is equal to whatever comes after. In this form, what we have here is a linear equation, or really, in this case, a linear function. So we need to put it in the form of a linear function, which is y equals mx plus b. You've probably seen this before. You probably saw it in high school, maybe even in middle school. When we're talking about a linear function, though, there are 2 big parts that we need to remember. One, m is the slope, and the slope is read as a fraction. You look at the sign of that fraction, the sign tells you whether you are increasing or decreasing. The top part of the fraction tells you how far to go up or down. The bottom part of the fraction tells you how far to go to the right. The b is the y-intercept, is the actual location where the graph crosses the y-axis. X and y are just values. So if I plug in a particular number for x, it will give me out a number for y, and these together make points on the graph. So for instance, the point -311 is present on our graph. So is the point 1, -1, and all of these other points that we found. Any questions? All right, well, we've got all this information. Why not graph the thing? Let's go ahead and do that. So I'll quickly sketch up something we can graph on. Okay. Now a quick crash course if you've never seen graphing before somehow. This is the y-axis. The y-axis is a vertical axis. This is the x-axis. It is a horizontal axis. Both of them are just number lines though. In the middle here is 0. We would call this middle point 0, 0 because it is 0 on the x and 0 on the y. Back here are negative numbers on the x. Over here are positive numbers on the x. Up here are positive numbers on the y. Down here are negative numbers on the y. So if we wanted to graph a point such as -311, like on our function, we would go to -3 on the x, 1, 2, 3, and positive 11 on the y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is right there. Here's one of our points. Okay, and we could put the rest of those points on here. They'd all fit, that's fine. But there's actually an easier way to do it, because we have some other information that helps us out. That being our y-intercept and our slope. So the y-intercept, we always know where that is. It's on the y-axis. It's just somewhere along that line. And our y-intercept for our example is 2, positive 2. So we're going to find positive 2 on our y-axis and put a dot there. All right, so how do we find the other dots? Well, again, we could plot the other stuff from our t-chart, but we can also use the slope, because the slope tells us, hey, we're going to go down 3 and over to the right 1 to get to the next point. So let's go ahead and do that. Again, it tells us to go down 1, 2, 3, and over to the right 1. So there's another point. Go down 1, 2, 3, and over to the right 1. There's another point. But as long as you have 3 points, you can make a graph. Connect up all these dots, and we've got the graph of our function. So like we can see, it's a negative slope, so we have a decreasing function, a decreasing graph. It's going down. Our slope is 3 over 1. 3 is a whole number. So it's going really fast. If it's a smaller and smaller fraction, it's going to go slower and slower. It's going to either increase or decrease slower. So what we can say about the slope is that as slope increases in, as the absolute value of the slope increases, I should say, then the graph itself, or the function itself, increases or decreases that much faster. Any questions? None? Makes sense? All right. So functions are intrinsically linked to graphs. Graphs are just a nice visual way to see a function, see what it does. If I bring this graph back over here, we can see that this function decreases over time as we increase our x values, and it does so pretty quickly. Not only that, but we can see from at least this slice of our function that it will do this forever. As we keep going this way, it will keep going down in a continuous line extending from here, and it will just keep doing that forever. So we can actually predict values on here. We can predict end behavior. We can do all sorts of things to predict what our function will do. That's why graphs are so nice. But sometimes we don't have a function. Sometimes what we have is a graph and we need to interpret the function from it. Like I said, functions are intrinsically linked to graphs, so that's actually something that is possible. For instance, let's say that we look at a graph and we glean some information from it. First of all, our slope, our m, is equal to -2. So we can find that by looking at our graph and counting how we get to the point before it. So like, okay, you need to go 1 on the x and 3 on the y. Well, there's my slope right there. Okay? So we can interpret that from looking at points on a graph. Another thing that we can interpret is the y-intercept. Now, Hawks will show you the y-intercept like this. It'll say f of 0 equals something. Anytime you see f of 0, that means you're at the y-axis. Okay, so again, what we want to do is we want to go from this information that we got from our graph to a function. Well, how do we do that? First of all, let me remind us what the function looks like. We know that it's a linear function by looking at the graph, so it should fit this form, y equals mx plus b. Once again, what do we do to get to our actual function? It's actually really easy. Do what? Turn m into a fraction? That's a good idea, yeah. It's always a good idea to have m as a fraction because it makes it easier to read. Not necessary in this case. Again, you could, it's just I'm not going to do it here because it's not necessary. Actually, what we need to do is just say, oh, this is m, plug it in. Oh, this is b, plug it in. That's it. So we get y equals -2 x plus -10. Well, that's really minus 10. So y equals -2 x minus 10. And there's our function. In other words, as soon as you know the slope and the y-intercept, you have a function. If you know those two pieces of information, you plug them into this form, and you have a function. Of course, I need to write this as f of x equals -2x minus 10, but still function. Any questions? Okay, so like I said before, once more, if I have my slope and my y-intercept, I have a function. So let me give you this question now. Let's say I don't even have the graph to look at. All I have are 2 points that are on the graph somewhere. They're not even necessarily the 2 points next to each other. They could be 2 points on opposite ends of the line. Of course, the line's infinite, but you know what I mean. As long as I have 2 points, I can come up with the function. Oh, whoops, not f of x. Let's do f of 6 equals 10. And f of negative 12 equals 11. So what do we have here? What does this mean? These are 2 points. For instance, the first one says f of 6 equals 10. What it's saying is if we plug in a 6 for x, what we get out for f of x is 10. Another way you could think about that is x is 6, y is 10. So again, this is our first point. I'll call it P1. P1 because it's the first point. Do the same thing with the other one, I'll call it the second point. But again, I'm saying that our x is negative 12, giving us a y of 11. So how do we get to an equation, to a function from this? Well, first we need to know the slope. And we have a formula for doing that. The formula says m slope is equal to y2 minus y1 all over x2 minus x1. Literally what this says is that the difference between the 2 y parts tells us how far apart they are. Same thing down here, the difference between the 2 x parts tells us how far apart they are. And that will give us some ratio between how far we need to go on the y and how far we need to go on the x that will give us the slope. So let's go ahead and plug things in. Of course, this is my first point, so I'll call this x1 and this y1. I'll call this one x2 and y2. It does not matter which one of these points you call point 1, point 2. It doesn't matter. What does matter is that if you call this one point 1, it needs to stay point 1. If you call this one point 2, it needs to stay point 2. You can't flip them. Okay? So now let's plug in values and see what we get. y2 is 11 minus, so this minus right here, y1 is 10. Now the x's, x2 is negative 12 minus x1 is 6. So let's see here. 11 minus 10 gives us what? 1. And then down on the bottom, negative 12 minus 6 gives us what? Not quite. They're both negative. They're going to combine to make a bigger negative number.
Negative 18.
Negative 18. Good. So our slope is negative 1 over 18. Okay, so that's nice to know. M equals negative 1 over 18. So that's one part that we need to know. We know that we need to know the slope and the y-intercept. So now we've got the slope. So how do we find the y-intercept? Well, there's another tool that we're going to need to use. It's called the point-slope form. You know how we have slope-intercept form? we also have a point slope form, and it's what allows us to use this to find our function. Okay, so here's how point slope goes. It's y minus y1 equals m times x minus x1. Okay? So again, y and x are just values. They're whatever we get when we plug in something. y1 and x1 are values that we know. We know y1 and x1. It's 10 and 6. So we can plug those in. Also, we know what m is. It's negative 1 over 18. So we can plug all these numbers in and figure out what our function looks like. So we have y minus y1. Again, we know what y1 is. It's 10. Equals m. We know what that is. It's negative 1 over 18. Times x minus x1. Again, we know what it is. We can plug it in. 6. And now all we need to do is simplify and solve. So let's distribute this first. So negative 1 over 18 times x is negative 1 over 18x. Or you could say x over 18, but this is more proper. And then negative 1 over 18 times 6. Does anybody know what that gives us? 6 over 18?
6 over 18?
Yeah, 6 over 18? Perfect, good. So plus 1/3. We still have y minus 10 over here. So there's only one thing left that we need to do to get y by itself. What do we need to do? Good. Add 10 to the other side. Okay, so now we get y equals negative 1 over 18 x plus, well, you could say 10 and a third, or you could write it as an improper fraction. That would be 31 over 3. And there's our function. And it's even in y equals mx plus b form. So 2 things that I want y'all to memorize, hopefully between now and when we meet again. Point slope form. Point slope form. If we have a point and we have a slope, we can find our function. And of course, all we need to find slope is 2 points because we have the slope formula. Any questions? Make sense? Sound good? Everybody cool? All right. So I believe that will do it for today. Again, though, remember, we are running out of time this semester. So we're quickly coming upon the exam, the final exam. Just remember that. Start getting your notes together so that you can study easily on those dead days and whatnot. Okay, and again, remember that the last week we will be doing our own reviews on Monday and Wednesdays so that we can be prepared for that exam. All right, so if there's no other questions, then y'all are free to go. I'll see you on Wednesday.
Have a good one.
You too. It's been a while, sir. Did you email me earlier?
Yes, sir. I was trying to, cause we had a grade check.
Yeah. Do you have a form for that?
No, sir.
No? Okay, let me check your grade real quick for you. I think you're doing fine. And if you're not, it'd be easy to make it up. Don't worry. Here. Oh, shoot. Oops. And let's see, Kendrick. What's your last name?
Jefferson.
Jefferson. It's loading up right now. There we go. Okay, what I need from you really is just exam 2 and 3.
2 and 3?
But I think I got 3 from you, didn't I?
Sure.
Yeah, there it is. So I've got it from you, it just isn't in the grade book quite yet.
Mm-hmm.
Okay?
So all I need is 2?
Wait, is that? Hold on. What the heck? Oh, okay. Something was up with it. It's working now. Okay, yeah. So I think. Oh no, you've got it. Yeah, no, you're fine. Never mind. Something's happened. Some reason I didn't get exam 2 in there, but I see it now, so I'll get that in there for you.
Okay.
Okay, so yeah, you're fine.
So
You're
after
good.
you grade those, am I going to be good?
Yeah, you'll have an A.
Okay.
I'm positive of it.
Okay, thank you. Have a good day.
You too.